Okay, so now we will discuss more advanced compound types. It is possible to define even more advanced compound types. For example, you can create a type where each element contains an array or matrix of values. Here we will create a data type with a mat component consisting of a 3 by 3 floating point matrix. So let's start. TP is equals to np dot dtype. Okay, so dtype, open bracket, square bracket, open bracket, id, then put a comma, then write i8, then put the bracket close down, then comma, then mat, then a bracket, then f8, then then two brackets, then square bracket, then close the bracket. Then x is equals to np dot zeros 1 d type equals to tp print x 0 print x match and the open square bracket 0. Then let's shift enter. Let's see our result. Now let's wait. We got the result. So now each element in the X arrays consists of an ID and a 3 by 3 matrix. So why would you use this rather than a simple multi-dimensional array or perhaps a Python dictionary? So the reason is that this NumPy D type directly maps onto a C structure within C structure definitions. So the buffer containing the array content can be accessed directly within an appropriately written C program. So if you find yourself writing a Python interface to a legacy C or Fortran library that manipulates structured data, you'll probably find structured arrays quite useful. Now, let's discuss record arrays, which are structured arrays with a twist. So NumPy also provides the np.rec array, that is record arrays class, which is almost identical to the structured arrays just described. But what with one key additional feature, that fields can be accessed as attributes rather than as dictionary keys. So you can recall that we previously accessed the ages by writing data square bracket. So if we view our data as a record array instead, we can access this with slightly few keystrokes. Data rec is equals to data dot view np dot rec array. Sorry, data. Okay, the downside is that for record arrays, there is some extra overhead involved accessing the fields even when using the same syntax. We can see this here. Time it, age, time it. Now let's run this and let it run for a while. So whether the more convenient notation is worth the additional overhead, that will depend on your own application. So let's for the while. So let's go to the pandas. Uh, we got the result. This section on structured and record arrays is purposely at the end of this section because it leads so well into the next package we will cover, that is pandas. Structured arrays like the ones discussed here are good to know about for certain situations, especially in case you're using Numpy arrays to map onto binary data formats in C, Fortran, or any other language. So for day-to-day use of structured data, the pandas package is a much better choice, and we'll dive into this full discussion into the next section.